just want to go over a little factoring review. We're going to do 5 questions. I'm going to try to talk through because all these factoring questions are going to be mixed up. So I want to talk about each one, kind of how we know what type of factoring question it is, and then we'll go from there. All right, so the first one up here, what you can do on this video as you're watching, maybe pause it, try to work it out yourself, and then go through and see if you got it right by watching me. This first problem here, though, when I look at it, first thing you want to do on every single factoring problem, see if you can take something out of all the terms. I have 4 terms up here. If I look at it right now, I can take something out of all 4. In fact, all of them have an x in common, so I know I can take that out. And by looking at it, that might be it. So let's take an x out. Let's see what we have left. So that's what I'm going to do first. So I'm going to go ahead and I'm going to take an x out of all of it. So that just means dividing each by x. Okay, when I do that, I am left with 15x squared plus 20x minus 6x minus 8. Okay, so I took an x out. Next thing I should look at, whatever I have left after I take out something, I should see if I can factor it. Since I have 4 terms, this is pretty clear cut. This will be a grouping problem. Okay, a grouping problem that I need to try to factor with grouping. So if you remember, what you do is you pair the first 2 up, and you take out what you have in common. Okay, both of those have the greatest common factor of 5x. So I'm going to take a 5x out. Okay, and I'm simply going to divide each of them by 5x and see what I have left. First term, when I take out a 5x, I have a 3x left. The second term, I end up having a 4. Since I got 3x plus 4 in parentheses, I should get it again when I take out something in the other 2 terms right here. Okay, so I have a minus that's already there, and 6 and 8 you can both take out a 2. So really I'm taking out a minus to a negative 2. So when you do that, notice how you get 3x plus 4 back. Okay, so what I have in common in both of those, I have both of them have a 3x plus 4. And when you factor it out of these 2 terms right here, you're left with a 5x minus 2. So 5x minus 2. And then I just need to remember at the end, I originally took out an x, so I'm going to go ahead and stick it back in front. So that's what this first one would factor out to. Okay, my second problem that I have is a trinomial. I got 3 terms. So again, just like I normally do, I'm going to look and see if I can take something out of all 3 terms. In this case, I can. I can take out a 2, so I'm going to do that first. I'm going to go ahead and take out a 2. I'm going to write what I have left. Okay, if I take out a 2 out of each term, I'm left with x squared minus 10x plus 21. Okay, and just like the last problem, what I have left in parentheses, I'm going to see if I can factor it. Since I have 3 terms, okay, right now it's not a grouping problem, it's a trinomial problem. Okay, so if you remember, no matter what with the trinomial problem, I need to make a t-chart. Okay, so I'm going to make a t-chart over here. Okay, so I need to find a number combination using a t-chart in which the numbers multiply to give me whatever a times c is, and the same numbers have to add to give me what b is. So in this problem, in the parentheses, your a times c, I have a 1 in front of x squared times a 21 at the end, so that's 21. And b in the part with parentheses is negative 10. So I need 2 numbers that multiply that give me positive 21, and the same 2 add to give me negative 10. Okay, in this case, negative 3 and negative 7 both multiply to give you positive 21, and the same 2 add to give you negative 10. So, right now, since I know that number combination, and I don't have a number currently in front of x squared, okay, because I already took a number out, you already know what this factors out to. In the parentheses, that part should factor out to x minus 3, x minus 7, and all I need to remember to do is bring my 2 out front, and I have my answer. Okay, for my third problem, I have another trinomial. So looking at it right away, I'm going to look and say, can I take something out of all 3 terms? And this one you cannot. So right away, you go to the t-chart like you would on every trinomial. So I'm going to go to my t-chart. And I want to figure out a number combination that multiplies to give me a times c and adds to give me what b is. In this problem, a times c, that would be 2 times negative 7, is negative 14. And my b in the problem is negative 13. So I need two numbers that multiply to give me negative 14. The same two numbers have to add to give me negative 13. You will figure out that combination is negative 14 and positive 1. So what's different than this problem than the last trinomial we did, since I have a number in front of x squared, what you need to do is you need to actually change this to a grouping problem. Okay, so if you don't remember, what that means is you take the first term, you keep it the same. You take the last term, you keep it the same. However, the middle term I need to split up into two terms that equals negative 13x, and this number combination tells me what to split it up with. So I'm going to use negative 14x and positive 1x. Okay, because negative 14 plus positive 1 equals negative 13x's. Now you've changed it into a grouping problem because you have four terms, and it's guaranteed to work because this number combination fitted the t-chart. Okay, it worked for it. So first two terms, I end up having a 2x in common. I take a 2x out of both. Okay, I am left with x minus 7. Okay, which means I should also get that in parentheses with the last two terms. So if you look at the last two, both of those don't have a number in common. Okay, so all they have is a 1 in common if they don't share anything. So if I take that out of both, notice how you get x minus 7 again. So at the end, both of these have an x minus 7 in common. And when you take that x minus 7 out, you're left with a 2x there and a plus 1 there. So 2x plus 1. So that would be the final factored answer for that trinomial. Okay, this fourth trinomial has two terms. It has two terms. I want to look at both terms and say, can I take anything out of both? In this one, you cannot. Okay, you cannot take anything out of both. Okay, however, this is one of those special cases. Okay, I have two terms. I have a minus in the middle. So as long as I know what times itself is the first term and what times itself is the last term, I can factor using conjugates. In this case, I actually know that. So this is a conjugate problem. Okay, so I'm going to put two parentheses. I'm going to have a plus and a minus in each of them, okay, opposite signs. And I'm going to ask myself, what times what is 9y to the fourth? And it has to be the same thing. So 3y squared times 3y squared is 9y to the fourth. Okay, and then I'll also ask myself, what times itself is 16x squared? That answer is 4x. 4x times itself is 16x squared, and that would be my final answer. So again, as long as you have two terms, you have a minus in the middle, okay, and you know what times itself is the first and last term, you can factor using conjugates. Okay, for my last example, I have two terms again, and I actually have a minus in the middle. However, on this one, there's nothing times itself that will equal the first term and nothing times itself that will equal the second term. Okay, so what I need to do is take out what they have in common. Maybe what I have left will factor with conjugates, maybe it won't. So I need to take out the greatest common factor of these two terms. The biggest number that goes into 24 and 36 is 12. Okay, both of them have an a in common. Both of them have a b squared in common. And they share two b's, and both of them have a c in common. So that is your greatest common factor. So what I'm going to do is I'm simply going to divide each of these by my greatest common factor. Okay, so I'm going to write that underneath. Okay, when I divide each of those by that, in the first term right here, okay, let me just circle it. Okay, when I divide that, 24 divided by 12 is 2. A cubed over a, one of the a's cancels out, so you're just left with an a squared. All the b's cancel out, and all the c's cancel out. So you're done with that first term. Then you have a minus sign. For my second term, 36 divided by 12 is 3. Okay, your a's cancel out, your b's cancel out, and and then all of your c's cancel out except for 1. Okay, so this would be my answer for that. What I want to check is this part right here. I want to see if I can factor again. Notice how it doesn't have anything in common. Okay, do I know what times itself is 2a squared? Okay, the answer is no. Do I know what times itself is 3c? The answer is no. So even though you had 2 terms and a minus in the middle, okay, this thing's completely factored because you cannot factor this part right here using conjugates. So my final answer, okay, when it's factored, would just be this right here that I originally